Okay, welcome back to another episode of Mr. A's Geometry Podcast. I'm glad you could join me once again. Today we're going to continue looking at inequality proofs. This one is just a little bit different than the one we did last time. It involves some midpoints, so there's a little bit more going on, but it's not bad at all. Let's take a look at what we have. So we're told that BD is less than BE, and we have two midpoints, D and E. If you're in my class, you recognize this one as homework from the other day. So let's mark up our picture. What do we know? Well, BD less than BE, so I can say this side is less than this side. I can use a little plus and a minus there to indicate that to myself. So however you want to mark it is fine. You may not want to mark it at all, but if it helps you, put something down on the paper. Then we are told that D is the midpoint of AB and E is the midpoint of BC. Okay, so what does that mean? Well, midpoints cut segments into two congruent segments. So DB is congruent to DA and BE is congruent to EC. Hopefully everyone's with me on that. We've been using midpoints for a while. So we're going to be able to use those midpoints to tie together two different pieces of the information here. We want to say that BA is less than BC. Well, BA is this whole side, and BC is this whole side. So if you want a statement in the end about large pieces, then that should tell you what kind of problem this is going to be. Addition, right? If you want to get to large pieces, you have to add. So this is going to be an addition problem. We just have to figure out how we're going to put it into place. Well, BD and BE, these are some of the pieces that we have. These two here. What do we have to add to BD to get BA? AD. And what do we have to add to BE to get BC? BC. So we need a statement about DA and EC. Some sort of relationship between the two of those so that we can do addition. So let's see what we have so far. Well, we already know that D is the midpoint of AB, and E is the midpoint of BC. So from that, we can make those two statements of congruent segments that we talked about. AD congruent to DB, and BE congruent to EC. My reason? Midpoint divide the segment into two congruent segments. Okay. So what we've done so far is taken midpoint, broken up those two segments. But remember, we're dealing with inequalities. So if you're dealing with an inequality, what should you be thinking about? Not congruence, equality, right? You have to work with measures and lengths. So if these segments are congruent, then it should be fair for me to say in step 3 that the lengths are equal, right? If AD is congruent to DB, then obviously the length AD equals length DB. And if BE is congruent to EC, then of course BE the length equals EC the length. My reason? Well, congruent segments have equal length. Nice and simple. Well, you might be wondering, why are we doing this in the first place? Well, this gets us set up to get our addition. Watch what happens here. I'm going to bring the other given in. Step 4. BD less than BE. There's a substitution here. Can you see it? It's one of these double substitutions where we're swapping both pieces of information out. What we're going to do is replace this BD with AD. And I'm going to replace this BE with EC. So when I do that, I have, instead of BD, AD, less than, instead of BE, I have AC. So this is substitution of inequalities. And remember, you want to tell me steps for substitution, 3 and 4. Well, look what we've done now. Remember, for addition, you need to have two lines to add together. Well, we knew that BD was less than BE originally, but we didn't have any connection between DA and EC. But now we do. We know that AD is less than EC. So remember, if you have two statements of inequality, and they're in the same order, these are both less than, we can add those together. That's exactly what we're going to do. We're going to say BD plus AD is less than, right, they're unequal in the same order, BE plus EC. That's addition. Oh, excuse me. With this one, you really need to be a little bit careful. Since this isn't addition of equals and unequals, we're doing unequals and unequals, so we want to say unequals added to unequals in the same order. Unequals added to unequals in the same order are unequal in the same order. I know it's kind of a mouthful, but it's important that we distinguish this because we're not using addition, right? Addition says when equals are added to unequals. That's not what's happening here. We're adding unequals to unequals. So we have to say unequals added to unequals in the same order. That means they're both less than or unequal in the same order. So that makes this step okay. Well, now we're very close to what we need. Just like any addition problem, once you do addition, you need some way to connect this to what you want, right? You want to say BD plus AD is AB. So how do we do that? Partition. So in step 7 here, you're going to tell me BD plus AD is the same as AB. And you're going to tell me that BE plus EC is the same as BC. Right? That's just partition. And then we're almost done. Once you do addition and you do partition, all that's left is a substitution. So we're going to take this step 6 and we're going to rewrite it down here. But instead of BD plus AD, now I can substitute AB. The less than sign carries forward, still less than. BE plus EC, well now I know that's just BC. And so there's what I want. My reason here is substitution of inequalities. And remember, like any substitution, you want to make sure to tell me what steps. So we are substituting step 6 and step 7. So 6, 7. Finish off with a box. So this is slightly more involved inequality proof. This time we had to do this little trick here, right? This little substitution in the beginning to get our second statement of inequality, so that we can then do our addition, partition, substitution. Remember, this little trick comes up a lot where you have 2 or 3 different things and you got to kind of double substitute to get what you want. So I hope you enjoyed this. I hope it helped. If you have any questions or if there's something you'd like me to do in particular, drop me an email or tell me in class. Thanks as always for watching, and stay tuned for the next inequality proof. Have a great night.